Hi everybody. So welcome to today's video, which is going to be based on the CPM lesson 6.2.1. I want to start by sharing the learning targets with you. The first learning target for today is that you will review what is meant by the LSRL and will observe its usefulness in determining how much a pizza should cost based on the number of toppings it has. And then the second thing is you'll determine if a linear model is a good fit for the data by creating and visually analyzing residual plots. All right, so basically what you're going to do is you're going to be watching me do these things, and then you'll be taking some notes on it on the Google Doc that I load onto Google Classroom. All right, let's start here with the CPM book. All right, so what we're going to do is, you can see this lesson starts with 647. We're not going to do that problem. We're going to start right away with 648. So what I'd like to do is just read it for you first, and then we'll go from there. So Julia's father would like to open a restaurant and is deciding how much to charge for the toppings on pizza. He sent Julia to 8 different Italian restaurants around town to find out how much they each charge. Julia returned with the following information. So you can see the information there in the chart. Basically, she took down information about what they charged for 1, 2, 3, 4, 5, up to 6 toppings. And even one, Rose's Restaurant, 0 toppings. All right, so Julia needs to write a report for her father about what he should charge for a 2-topping pizza. So what we're going to do is use some of the information that we've already learned to do this. I'm going to scroll down just a little bit. I want to go down to the math notes for today because the math notes review what we're going to use here. All right, so here is the definition for the least squares regression line. And what I want to do is just come down here. A unique best line fit for data can be found by determining the line that makes the residuals, and hence the square of the residuals as small as possible. We call this the least squares regression line and abbreviate it LSRL. A calculator can find that quickly, right? And then they say statisticians prefer the LSRL to some other best fit lines because there's one unique LSRL for any set of data. All statisticians therefore come up with exactly the same best fit line and can use it to make similar descriptions of and predictions from the scattered data. Okay, so what you'll see right here is I have loaded the data in that Julia picked up from the pizza. All right, now I'm going to put in the formula for the LSRL. So remember that's Y1 tilde M X1 plus B. All right, now once you get here, you can see right away the line of best fit. And for a 2-topping pizza, based on the information here, I'm going to say that's about $10.50, right? So in terms of this, basically you could write the report based on what you've just done here. All right, but what I'd like us to do is I'd like us to actually use some of these other tools to see if this really is a good line of best fit. All right, so I want you to watch what I do because this is going to show up on a couple of other graphs. See where it says residuals here? You hit plot. First of all, did you see what happened to the table? Right? And then did you see what showed up down here? This actually is a residual plot for the line that we just drew. Right? And if you look, you can kind of see, oh yeah, all right, this one is just about on the line. Here it is, almost right on the 0. This next one, about 1.5 above the line. Oh yeah, 1.5 above the line. So remember, the residual is the difference between the actual and the predicted. So the actual is about 2.5 below the predicted. If you look here on a 3-topping pizza, we have 2 values. One residual is just a little bit above the prediction, and one is almost like 3 below. Same here, you can see that here. So it's almost as if you take the line and flatten it out and bring it down here. right? So you can basically see what happens. Here's your residual plot. All right, so what I want to do is go back. All right, I want us to go back up to the problems. And what I'd like us to do is use what we just discussed to do number 649. All right, so what we're going to do is we're going to try to match each scatter plot with its residual plot. Now, if you'd like, you could stop this and try it on your own, but you don't have to. I'm going to actually give you a little bit more information before we do this. Right? I think it helps if we can actually show pretty drastic residual plots. All right, so I've already graphed a few things on Desmos Graphing Calculator. This right here is an exponential function. So, but what I'm going to do to kind of make it really clear about what happens to the residual plots is I'm going to try to figure out a line of best fit. There really isn't one because it should be a curve, but I just want you to see what happens to the residual plot. So again, y1 tilde m x1 plus b. Okay, so there you can see, yeah. In fact, oh, you know what? The residual plot already came up because I had done it before. Right, so I want you to see what's happened here. We've got a line, right? Our curve is actually the one that I've connected in purple. The residual plot is in blue here. And you see the residual plot itself is curved. That means that the points themselves create a curved pattern when you compare them with the line. And that means that is not a good line of fit at all. It really gives you an indication that the actual best fit here would be some sort of curved line, right? So I wanted to show you that. By the way, again, you can see the residuals have showed up. You can also see a pattern here. It's like just looking at this above the line, below, 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 and then back above, right? That creates this curve. All right, so not a good line. So if the residual plot makes some sort of curve, it's not a good line of fit. Now, if you look at this one, you can see I've graphed some points here. As the x values increase, y values get further apart. Right? Let's see what that looks like when we actually graph the residuals. So again, y1 tilde m x1, whoops, 1 plus b. All right, so you can see the residual plot here is pretty good at the beginning where it's pretty close to 0, but then it starts getting more erratic. You know, it's up and down. You can see as you go along, it sort of loses it as it gets higher in the x values. So this, again, not really a good fit. I don't know what would be a good fit for this because it looks like some of it's going up and some of it's going down. There's just really no pattern for this one, is what I would say. The data is really erratic. All right, on the other hand, if you look at this, I've put in some data that you can see right away. There's going to be a line that's going to work really well. All right, so watch what happens to the residual here as you put this in. All right, whoops, did that wrong. It's a problem. There we go. All right, so you can see that the residual plot here, which is in blue, one, it's really close to the line. And there's no curve here. It's kind of, you know, no predictable pattern of up and down, but basically because it's some up, some down, that makes it a pretty good line of fit. All right, so I want us to use that when we're looking at these here. All right, so there's a couple ways to figure out what goes with what. And then there's a few ways to figure out which one's the best fit. Okay, so first of all, I'm looking at this scatter plot 1, and I'm just kind of paying attention to right over here near the 0. There's only one residual. If I'm looking over here at this plot A, you can see there's 3 right here. So this is not a good match. I'm looking over here, there's two and they're really far apart, so that's not a good match either. Look here. Okay, residual plot C, I think it's this one, right? I'm going to just kind of take a look at the end here. If I'm looking over here, way on the right, I see there is one that's a positive residual, two that's a negative. Yep, one positive, two negative. Guess what? Scatter plot 1 goes with residual plot C. All right, so I can eliminate that one. For scatter plot 2, I can see, well, right here near the beginning, there's one that's a positive, one that's a negative. Then you've got a couple below here. Again, if I'm looking at residual plot A, it really does look like there's 3 here. One slightly positive, one more positive, and one negative. So I think the best fit for 2 is residual plot B, and then the best for 3 is residual plot A. All right, and I can tell you I already checked the answer key, and that's correct. So scatter plot 1 goes with C, scatter plot 2 goes with B, and scatter plot 3 goes with A. The other thing you're asked to do here is say which is a line of best fit. If I'm looking at the residual plot, I'm going to use some of the things we just talked about. Even though it's not as clear, this one's a bit of a curve. Kind of goes like a U shape. That means that which goes with this one, is not necessarily the line of best fit. All right, you can see here's kind of more of a bit of a curve. If you're looking at B, that one is actually kind of evenly spaced. I would say my guess is, even though it's not close to 0, they're more evenly spaced in terms of the lines. So my guess is it's scatter plot 2 that's the best fit. If I'm looking at 1 that goes with C, you can see, just like one of the ones we looked at in an extreme example, as the X values increase, the Y values are spread further apart here, so the residuals are further apart as X increases. So that's not the greatest pattern either. Again, I think this would not be a pattern at all. I think it would be hard to find a line. All right, so the best linear model, if you have to pick one, is scatter plot 2, even though I don't think this is all that great. I might be looking for some other information. Let's just say it's kind of a weak in strength. All right. What I'd like to do next is we're going to take a look again at Julia's results, and I'm going to show you a couple of things here. So mark the residuals, just ignore my phone there. Mark the residuals on the scatter plot you created in 648. All right, we already did that. If you want to purchase an inexpensive pizza, should you go to a store with a positive or negative residual? Well, I hope this makes sense to you. You should go to a store with a negative residual, because that means the actual cost is going to be below the predicted. All right, the next thing we had to do is find the sum of the residuals. So I want to show you what I did here. I put the residuals in a spreadsheet because this is a real quick and easy way to figure out the sum of the residuals. All right, so watch what happens here. I'm going to click this box here, and I am going to insert a function. All right, so insert. I'm going to insert a function, and the one I'm going to use is sum. Right, and then what I'm going to do is just highlight this. Watch what happens next to the sum. I am going to find the sum of everything from cell C2 to cell C9. All right, so I'm just going to hit the enter button. Oh, and look what happens. It gives me the sum here. So note, if you're ever working on a spreadsheet, you're not sure what the function was that you put in here, you can look back up here. All right, the sum of the residuals is 0, which is cool. It asked if I was surprised at this result. I was not, because we actually figured out that was a pretty good line of fit. And the closer the sum of the residuals is to 0, generally the better line of fit, unless they're way, way apart, but that wasn't too bad. In C, we were asked to determine if this linear model was a good fit for the data, right? And we actually, here's the data again, already determined that it was, right? So I'm back to then the best price for a 2-topping pizza is $10.50. All right, so I'd say we met our targets. Nice job, everyone.